Hey guys, just a few notes to help you out with homework 3 here. Uh, for the future homeworks and actually future activities, we're going to be relying very heavily on the package that I've written for the class, package reg class. So one thing you're always going to want to do when you load up our studio is to run the command, you can type it down here, run the command library reg class, because that will load up all the commands that have been written, all the data sets that have been written as well. So if you don't do this and you try running, say, associate, or try to load up a data set, it'll say, hey, I can't find this function. So when you see that, that just means, oh, you haven't done library reg class yet. Okay, so for question 1, you're going to be dealing with the tips data set, and it's pretty easy to load it up because it's one of those data sets that's included in the reg class package. So running tips data tips will go ahead and read that in to the environment so that you can actually work with it. So parts A and B are pretty straightforward. You'll just run the core matrix command and let's see, yeah, so you'll run the core matrix command for A. And if you ever need to remind yourself how a command works, remember you can always do question mark and then the name of the command. So that will tell you the arguments that it takes and what you can do to customize that command. So for A, you're going to find the Pearson correlations with bill, tip, and party size between that and tip percentage, and you're going to rank them from strongest to weakest here. For part B, what you're going to do is you're going to play around a little bit with the plot command. You're going to look at the relationship between tip percentage and bill. And the first plot is just going to be the default plot. So if I go ahead and do this, run plot using the default plot y twiddle x, data equals data, replacing x and y in data with the relevant names. So in this case, I know my y variable is tip percentage because that's really the thing I'm interested in. That's the thing I'm going to try to predict based on bill. So I'll say plot tip percentage twiddle bill, and then I got to tell it what data frame that's in. And if I just run this, I see that's my default scatter plot. And the second part has you modify that scatter plot. So R has a lot of customizability when it comes to making plots. And so in this case, we're going to just copy and paste this command and add some additional arguments so that the limits of the plot are changed and the sizes of the points are changed as well. So the second plot needs to have the y-axis go from 0 to 30. So I can add an additional argument, ylim, and then have that equal to c, and then in parentheses, the two numbers that I want the lower and upper limits to be. So 0, 30. And then I also want to have the plot have small solid points, so I can change the size of the points, or the point type, by saying PCH equals 20. That makes it small round circles instead of open circles here. And I'm also telling you to add the additional argument CEX equals 0.5 so that those points are extra small. So there's my scatter plot with the new axis and the new point shape. Notice if I had left off that CEX argument, the points would have been a little bit bigger. And so since there's a lot of data points here, I like having those points a little bit smaller so I can see all of them pretty easily. Okay. For part C, you're just going to be running associate and finding Pearson's R and squaring it, interpreting the value. And you'll be answering whether or not it is statistically significant, that association, for part B, and also commenting on if it holds practical significance, if that relationship is strong. So that's always in the eye of the beholder, so comment on what your opinion is. There's no right or wrong answer for that. All right, so part E asks you to examine a different association and pretty much respond the same thing. Okay, question 2, you're going to be working with one of the Kaggle.com data sets, and so you're going to have to download that file into your BAS320 folder, and then once you do, you're going to be using the read.csv command to get that in. So we can give it a name, which I suggest hazard, left arrow, and then read.csv, and the name of the file. So if you set everything up, and this is in your BAS320 folder, this will just run. Mine I don't think is set up right yet, so if you do get that message that says, hey, I can't find that file, make sure to move it into your BAS320 folder. That'll probably solve it. If not, you can always go into Session, Set Working Directory, and Choose Directory, and actually navigate to where that file is. So for me, I keep my stuff a bit more organized, and so I'm putting that file into homework 3 folder here. I see it's located in there, so I'll just click open. So we can see that it set the working directory to where that file is, same sort of path up here. And so now when I try to read it in, that'll be successful. Okay, so you'll be running all.correlations to find the 5 variables whose Pearson's correlations with hazard are the strongest. And so, as a reminder, you can always do $all.correlations to bring up the help menu for how to actually do this. So the first argument is the name of your data frame, hazard. Type is going to be Pearson by default, so you don't even have to include that argument. And since we're only interested in the correlation with the variable hazard, you're going to put in interest equals and then in double quotes hazard. And then in this case, we're going to want to sort the results based on the strength of the relationship. So if you look at this sorted argument by default, it doesn't do any sorting. And if I go down to the description, you can either sort by strength or significance. So putting sorted equals strength in double quotes will get you there. All right, so you will run associate between that variable and the column hazard and make a comment here. You'll make a comment about when you should be using Pearson versus Spearman's rank correlation, the statistical significance of that association, and then you'll move into question 3. So question 3 is actually one you're going to have to complete after you've completed the rest of the assignment and printed it out. So when you compile this or knit this into a Word document or into an HTML, it's going to make 4 blank plots for you. So after it's been printed out, that's when you're going to manually put dots on these plots to give streams of points that meet these characteristics here. For question 4, what you're going to do is visit a website. Now notice when I knit this, the website doesn't actually appear, but the website is inside the document. So I've already loaded up this website, and we're going to discover a spurious correlation. So we've talked about that the existence of a correlation, no matter how strong or statistically significant, is not necessarily proof that there's a cause and effect relationship going on between them. And this website is dedicated to a whole bunch of spurious correlations, things that are not related by cause and effect, but have very strong correlations regardless. So what you're going to do is you're going to choose some interesting variables. So here are some choices that you can do. You can actually just leave it as interesting variables. It's kind of a hodgepodge of different ones. So maybe I'm interested in looking at the amount of sunlight each state gets. And what are the things that have really high correlations with this? Well, I'm going to choose Tennessee, of course. Once we click correlate, it gives us all the things that have very high correlations with it, going from most positive up at the top to most negative actually on the bottom. So one interesting thing is that the one at the very top looks like there's a perfect correlation between the sunlight in Tennessee and the amount of sales at Staples. And so we see a correlation of 1, but there's only 2 points involved. So that's not an acceptable choice according to my criteria here. What you're going to want to make sure to do is choose something that has at least 8 observations. So that's not acceptable. I'm going to click the back button, and I'm going to scroll all the way down to the bottom and see this correlation, see if it's acceptable. So we only have 4 points here, so I'm going to ignore that, go back, and maybe be a little bit more careful on what I'm looking at. This gives you a little bit of a preview for how many data points are in the data set. So you want to find something that has more than, or that's 8 or more years here. So let's go here. This one's going to have 12 data points. And so we're looking at the correlation between the amount of sunlight in Tennessee and the number of bus occupants killed while they're trying to board a bus. I didn't even know those things existed, but we see that there's a fairly strong positive correlation, and obviously there's no cause and effect relationship going on between these two, or at least probably not. I don't know, maybe if it is super sunny out, it's harder to see, so there's accidents can happen. That's a potential explanation, but there's no obvious cause and effect relationship going on. So this is probably one of those spurious relationships that just arose kind of by accident, just by chance alone. When we do see a strong correlation, it's either due to cause and effect, or just by random chance, or due to some sort of lurking variable, something that might be driving the relationship between the two quantities. And so based on what you choose, you're going to make a comment about why that correlation might exist. So there's three possibilities. There actually is a cause and effect relationship between them. The association arose just by random chance, or that there's some sort of lurking variable inducing the association. So give that a little bit of a thought and come up with a theory why there might be a correlation. If there's really no theory, then it probably just happened by chance. All right, and also once you've chosen what you want to be looking at, you're going to copy that URL, and you're just going to go ahead and paste that inside the parentheses here, so that, oh no, I lied. What you need to do is you need to right-click on the image, and you're going to copy the image URL, and we're going to paste that inside the parentheses here so that that picture is included in the write-up. So don't copy and paste the website, you're going to copy and paste that image so we see that it appears here, and that's great. Okay, now for the last question, what you're going to do is you're going to play around with a function called CoreDemo. And CoreDemo doesn't take any arguments, so it's just CoreDemo and then some empty parentheses. CoreDemo lets you add points to a scatter plot just to see, what does various correlations look like, what happens to a correlation when I add a point. And so for question A, you're going to make a scatter plot that has a correlation of about minus 0.8, give or take 0.05. And so you're going to play around and you're going to kind of add points until you get something that looks like it has a correlation of 0.8 here. So I say have this correlation be displayed in the upper right. It's fine if it's also in the upper left here. We're not going to be picky about this one. So here I'm kind of approaching there. It's almost 0.8. All right, so this looks like a correlation of 0.8. Oh, that's positive 0.8. You're asked for minus 0.8, so you can't use this plot here. But once you've gotten your scatter plot, you're going to click the End button here, and then you're going to export this as an image because we're going to include this into our studio. So what you're going to do is you're going to give it the name Homework 3 Q5A. By default, it's going to append .png to it, so you don't have to do that. And you'll notice that it probably is going to save into the same folder that your RMD file is, your BAS320 folder. If not, you're going to want to navigate there so that it compiles correctly. So I'll say save. That saved it. And then what you're going to do is you are going to remove the symbol to the left of the image name, and then the image to the right, or the symbols to the right of that image name. So you're going to have exclamation point, then the square brackets, Q5A, and then in parentheses, the name of the file you just saved. And so as long as that file is in the same folder as your homework3.rmd file, then it will include that now into the write-up. So you'll do the same thing for B, making a scatter plot with a different set of conditions. You'll save that to homework3q5b.png, delete the symbols on the left and to the right, and then do the same thing for part C. So that's a quick walkthrough on the homework, and just remember that it is due to me by 3:30 on Tuesday.